Bismillah ar-Rahman ar-Rahim. In this video, I'm going to talk about cardiac output, how to calculate cardiac output, how to evaluate mathematically. First, cardiac output is the amount of the blood that the heart pumps within 1 minute to our body in 1 minute. And the normal range of the cardiac output 4 to 8 liter per minute. And maybe the body needs more, so it'll be maybe more than 8 minutes in hard exercises, not as, for example, as the rest. Now, how to calculate cardiac output formula is equal to stroke volume, which is the preload and afterload. Stroke volume is the end of diastolic volume minus the end of systole times heart rate. So stroke volume is equal to end of diastolic volume minus end of systolic volume times heart rate. This is the cardiac output formula. Example number one. In this example number one, if the stroke volume is 70, given is 70. Here we have stroke volume is given 70, okay? It is 70 ml, and heart rate given 75 beats per minute. So how to find cardiac output? So the cardiac output is equal to stroke volume times heart rate equal to stroke volume is 70 ml times heart rate given 75, so it is equal 5,250, this one. So that is mean equal to divided by 1,000 because this is ml, so that means 5.25 liter per minute because this is ml, liter per minute. So divided by 1,000. That's in case if stroke volume 70 within the range and the heart rate, it is normal 75. So our body need 5.25 and the heart will be pumps 5.25 liters per minute for each 1 minute. Example 2. In case if stroke volume is 70 and the heart rate is increased. See, in the formula, our formula is equal the cardiac output stroke volume times heart rate. So that means if heart rate increase, multiplication, so cardiac output will be increased. See, in this example 2, stroke volume is 70, example 2, and heart rate now is 100 beats per minute. What about the cardiac output? So the cardiac output equal to stroke volume 70 times heart rate is 100, so equal to 7,000 milliliter per minute. That's what means 7 liter per minute. Will be more in the previous example 5.25, and in this example 7 liter. Why? Because the heart rate increased from that one 75 heartbeats to what 200 100 beats per minute. That's one from heartbeat from I said 75 heartbeat per minute. Now this one beats 100 per minute will be more. The cardiac output will be more. In this example number 3, if the end of diastolic volume 90 and end of systolic volume is 30, now what we have stroke volume will be 60. Why? Because preload and afterload 90 minus 30 is 60 stroke volume. Now what about the cardiac output? If the heart rate beats, and the heart rate will be 80 beats per minute. So the cardiac output equal to stroke volume multiplied by heart rate. Stroke volume equal end of diastolic volume, which is 90, minus ESV, which is end systolic volume, which is 30, multiplied by the heart rate is times 80, equal to, this one is 60 ml times 80 beats per minute, so equal to 4,800, 6 by 8, 48. That is me, this is ml. That's me will be 4.8 liter per minute in this example. Why? Because the stroke volume is decreased and the heart rate also decreased less than 100. So then the heart will be pumped 4.8 liter per minute for each minute in this case. Now, example number 4. In example number 4, assume given, it is known, cardiac output is 7.7 liter per minute and heart rate is 110 beats per minute. How to find the stroke volume in this example? How to find the stroke volume? So cardiac output equal to stroke volume. Let's use this red color I'm using here, unknown, stroke volume unknown, multiply by heart rate times H, heart rate. Stroke volume is given 7.7. This one is mean 7,700 ml. Because this is, I'll talk about this in ml. Okay, that's liter per minute. So now, 7,700 cardiac output milliliters per minute equal to unknown. Stroke volume is unknown. Stroke volume, it is unknown. Okay, unknown. Then multiply by heart rate given 110. Divide by 110. That is mean 7,700 divide by 110 equal to divide both sides by 110. Here what you have stroke volume. This one is the stroke volume. This will be 1. Okay, divide by 110 both sides. Now that is means stroke volume equal divide by 100 will be, this one is 70070. So it will be 70 stroke volume. So the stroke volume in this case 70. See, 70 stroke volume, heart rate 110. That is mean the cardiac output is 7.7 with 7,700 ml per minute. Example, another example here. Okay, example 4. Okay, this example 3, 4, the example 5. Example 5. Assume that cardiac output also now, it is now 6.3.25 liter per minute. Yani mean, this one mean the cardiac output is 6,325 ml. Okay, per minute. Heart rate is 115 beats per minute. And systolic volume, ESV, 50 ml. Now, unknown, stroke volume unknown, but which is another part? The part is EDV, which is the end diastolic volume. So how to find end diastolic volume? I'm repeating again. If given, now, cardiac output, heart rate, and systolic volume. How to find end diastolic volume in this problem, in this question? Now, the solution is cardiac output equal to what? Stroke volume times heart rate. This one is cardiac output, which is given 6.325. That means 6,325. Stroke volume, here we have end of diastolic volume as unknown, and diastolic volume EDV minus and systolic volume given 50 multiply by times heart rate given 115 115. Now how to find now this one? See, now EDV first divide by 115. So then now end this one and diastolic volume minus 50 equal what? Equal to 6,325 we divide by 115 both sides. So this side will be 1 here, 115, here divide by 115, which is equal to this one is 55. Then we have end diastolic volume, the end diastolic volume minus 50 equal 55. So that is mean the end diastolic volume, we have to shift this one to move to the side, to the right equal. So end diastolic volume equal to 55 plus 50, which is equal 105 ml.